Okay, so in 7.3, we're going to be using elimination to solve systems of equations. So again, we're going to have two equations, but in 7.2, we learned substitution to solve them. Now we're going to learn another method called elimination. So we have to have special problems to be able to do this. So my first problem is x minus 3y equals 7, and 3x plus 3y equals 9. So this one is really good for elimination. It's all set for it because I have a negative 3y and I have a positive 3y. So that's you're gonna have to find that in the equations when you want to use elimination, where you have the same number, 3, one being negative and one being positive, and it's the same variable. When you have that, you're going to be able to add the equations together. So we will always add our equations together. I have 1x plus 3x equals 4x. The negative 3y plus the 3y gives me 0, so therefore this cancels out the y's get eliminated. The 7 plus 9 is 16. I gotta get x alone, so I'm dividing by 4, and x equals 4. Once I have this, I have to use substitution to finish. So I go back and grab one of the original equations. I'm going to do x minus 3y equals 7. And I've got to substitute in, the x is 4, so I'm going to substitute that in. So 4 minus 3y equals 7. Subtract 4. Negative 3y equals 3. Divide by negative 3. And y equals negative 1. So I have found my x and y. X is 4, y is negative 1. And when it is set up this way to do elimination, it's nice and easy. However, it's not always set up to do that. So I'm going to do this next problem. 6x plus 5y equals 4, and 6x minus 7y equals negative 20. So I've got the same number, 6x and 6x, but I need to have one be negative and one be positive. Well, I can make that happen by taking the top equation, or either equation, and multiplying everything by negative 1. When I do that, my top equation becomes negative 6x minus 5y equals negative 4. Now I've got the positive 6x and negative 6x, so I can add my equations together. When I do that, the x's cancel. I get negative 12y equals negative 24. Divide by negative 12, and y equals 2. I'll go and grab one of my original equations, and now that I know that y equals 2, I'm going to substitute it in. So 6x plus 5 times 2 equals 4. 6x plus 10 equals 4 minus 10. 6x equals negative 6. Divide by 6. X equals negative 1. So my ordered pair is negative 1, positive 2. Okay, we're going to try a couple more. The next problem, oops, that's not right. C minus 3D equals 11. 2C minus 3D equals 16. So this time I have negative 3D and negative 3D. I need one of them to be positive and one stay negative. So I'm going to multiply the top equation by negative 1. Make sure you're multiplying everything by negative 1. That gives me negative C plus 3D equals negative 11. I'm going to add my equations together. So we're always adding, we're always making sure one's negative, one's positive, and we're adding. 2c plus negative c is c. The d is canceled. 16 plus negative 11 is 5. Okay, I've got my c. I'm going to go take this original equation, c minus 3d equals 11. I know the c equals 5. Substitute it in. 5 minus 3d equals 11 minus 5. Negative 3d equals 6. Divide by negative 3. D equals negative 2. My ordered pair, so it's got to be a C first and then a D, always alphabetical order. 5, negative 2. Okay. The next problem, we're going to do 4x plus 2y equals 6, and 4x plus 4y equals 10. I'd like you to put this on pause and you try this problem. Okay, when I did the problem, I realized that I have a positive 4 and a positive 4. So I'm going to multiply one of the equations by negative 1, and that equation turns to negative 4x minus 2y equals negative 6. I'll add the equations together. The x's cancel. I get 2y equals 4, divide by 2. So y equals 2. I'm going to take one of my original equations and substitute in 2 for the y. Y equaled 2. So I have 4x plus 2 times 2 equals 6. 4x plus 4 equals 6. Subtract the 4, and 4x equals 2. Don't make a mistake at this late point. Divide both sides by 4, and x equals 2 over 4, which is the same as 1/2. So you might get fractions, could definitely happen. The ordered pair is 1/2, 2. Okay, let's just do one problem. And again, I want you to do it. 5x minus y equals 6. 5x plus 2y equals 3. Put this on pause and you go ahead and do it. I'll do it quickly, multiplying one equation by negative 1 because my 5's were both positive. Negative 5x plus 2y equals negative 6. X's cancel. 4y equals, I think I did something wrong. Yeah, I made a mistake right here. This was going to be plus 1y. So when I add them together, I have 2y plus 1y is 3y equals negative 3. Divide by 3. Y equals negative 1. I'm going to take one of the original equations, substitute in negative 1 for y. That's 5x minus negative 1. So that's 5x plus 1. Subtract 1. 5x equals 5. Divide by 5. X equals 1. The ordered pair is 1, negative 1.